My dream job was to become the Capcom. That is in your shuttle mission. If you have watched, there is a one person who actually communicates with the astronauts, who is going around in the space. So that is he is actually called, the position is called the Capcom. That is a captain of the communication. So I dreamt about that job, going into that, and maybe I would one day I will become the Capcom or the communication specialist to talk to these astronauts for the Indian mission. So I had that in mind. And anyway, that dream is still to be reached. In my innings, I'm out of the service now, so it is only some of you are going to have that the beautiful opportunity of being in contact with the astronauts. The intention of getting into the space is always intriguing. See, everybody wants to explore, and it's a human tendency, because they are not satisfied with what they are and how they are and where they are. They try to explore. Even whenever we go to a new place and we keep on moving from what is going on, we explore the food culture, we explore the environment. If you look at it, the history of the space, what happens is that the first few decades of the space exploration, it was enough who gets there first, who gets there, and then so that was the first few decades of the space activities were all confined to, like for example, people would say there is a race between America and then US, erstwhile USSR, who will go to the space first. Then the next another 2 decades, it's not that we are getting into the space is important. Can you do something in space? That means can you make money out of space? So that is another 2-3 decades how people have spent in making money out of space, because whether it is now the present decade or the future, what it is it's, as all of you know, it is more than commercial, and it is certain way, if you look at it, it is a non-commercial activities are being talked about. So that's why always the space is something intriguing to the humankind. What is so special about the space? If you look at it, there are a few parameters which are different from what we are used to. One is that extreme temperature that what anybody can experience. It's minus 269 degree Celsius or the 4 degree Kelvin, if the people say. And when you see the sun, so that means 100% sunlight, depending on the surface what you are having, you get exposed to that high temperature. Not only that, in the absence of the atmosphere is expected to give you a certain amount of protection. So the protection is also lost, or exposed to both good radiations and as well as the other unkind radiations. And another aspect of this is that your gravitational force seems to be much when you go away from the body like Earth. So how do you handle these kind of things? This is the challenges that put every space engineer, every space scientist, then they will come up with whatever that handle. So whenever they wanted to go to the space, whenever they wanted to make money from the space, everything is, for me, working in it's basically when you work in the space or when you go up in the space, I consider that it sharpens your mind and thinking and your outlook. See, as you go higher and higher, you get a different view about the things that what you have. If you, like my seniors used to say to me, if you have an agitated mind, go and look at the fish tank, how the fish are moving inside the tank, and handling this kind of a thing is that, you look at the map of the universe, where that means, and also if you look at it, like for example, nowadays people are used to the satellite maps. If you go on, even in your mobiles, you are having that your satellite map, or you are trying to locate your own interested places. As you move and higher and higher, you get a different perspective. So this is the experience which translates into the actions and what we have. If you try to do something, if you try to achieve, and if you achieve something where others say you can't do it, the satisfaction is always something different. So initially when somebody says you can't go to, people like for example, in a country like India, where we have been not so fortunate to have that type of economy in the beginning, as is immediately after the independence, where we had decades back, when somebody talks about going to space, and we are all ridiculed, and anything that whatever you try to spend, and it's all being ridiculed, and then nobody was trying to appreciate what the things were going on. And if in that such a scenario, if you show that you are able to do something that gave give a lot of appreciation or a self-satisfaction that whatever there is there. That is one thing. And initially, whatever used to happen, those who are able to go back to the history of overcoming that type of culture had been one of the tremendous work pressure every one of us had in those days. If you answer all those kind of things, it's not necessary that outsiders can succeed. We can also succeed, and we can also bring change into our kind of setup. We have been fortunate enough to be guided by some of the visionaries in the early ages. One of them was, you would have you would have seen the quotes of Vikram Sarabhai, who had that, is an entrepreneur who believed that space can change the social fabric of India immediately after the independence. If we have the talent pool, unless that we overcome the difficulties, a leapfrog in technology, we will not be able to answer the needs of the country. So that is how he sowed the seeds of the organization, and later on it became the Indian Space Research Organization. Okay, failure can happen. I personally believe that don't accept the phrase on its face value. The steps are not uniform. If you keep on repeating the same thing again and again and expecting different results, it's not going to come unless you understand why it failed, how it failed, and wonder what condition that you made a mistake. See, the key issue for your success is understanding the failure. So this is where for example, only a handful of people are fortunate to go to space and see what is really happening, how they can. All other people are not actually visited, but only in the simulation conditions they experience what it is, they realize what is it, they study about the space. There are various aspects of the space that have been studied, and you're trying to understand what is the thing. Okay, you're trying to simulate. See, for example, if I want to simulate the near zero gravity, sitting in a gravity, how do I do it? This is a challenge, and you cannot put your satellites into that type of situation and make crazy. So what you try to do is that we go with what is called the balloon technology. Suppose your counterweights are put in such a way with the inert gases are filled with the balloons, that those acting as a counterweight. So you will create the environment where that this kind of, suppose even if your mechanism, if you are designing, and if your mechanism has to work in a zero gravity condition, what is the way, how do you test that it is going to work in a zero gravity condition? So this is the kind of learning that the thing. How do you take the whatever it is possible to it in the ground, you do it. Your design or your product is having a failure and it is not meeting the end goal that what it is there. Sit down and understand why it failed, what was there, where did we go wrong, and it's ultimately it is until and unless, because you have all the variables and you have made certain assumptions and you have given certain tolerance values, or you have made certain provisions for some of the variables, but there may be another variable which you have not thought of. So for example, if you allow me, just simple fact, I want how we actually changed so much of the thing. Now we have launched first communication satellite in somewhere in 1982. Apple, you would have studied. In 1975 or 78, there was a special team was organized. Now we have put the specific team worked out and once in a while, please give me a feedback, okay? Otherwise,
Yes, sir. You're audible, sir.
See, earlier satellites, whatever you had seen, it is a spinner. That is basically a drum type of a cylinder type of situation that used to have, and that used because the physics says that any rotating body gives you some kind of rigidity. Essentially, if you are able to look into it, it is just like a box type of. It's a cuboid. See, it's supposed to be weighing around somewhere around 1,000 kilogram, because the launch vehicles were capable of around that time 1,000 kilogram, 1,500 kilograms only for commercial use. This is the kind of a satellite. So this is the INSAT 1A. We had INSAT 1. We contracted for 1A and 1B. It is a multi-purpose satellite. It is all technology put together. Everybody wanted this, but it is one of the beautiful design concepts. And when we trying to realize that, So we had, there is, I will come to it failed. It launched and it got into problem. It worked for some hardly about, it was launched in April, but it didn't survive beyond September of 1982. It failed. I will come to that, the failure, what lessons it gave later. But the other aspect of there's another satellite which came the follow-up. It is totally, this is the kind of structure what you will going to have. But you can't fly like this. So what it used to have is that it used to be folded, like so many folds it used to have, and finally it is there. So some of the designers used to say it is an origami satellite. So it has got so many folds. Mind you, the batteries what we are today, we are talking about batteries of larger capacity. Those days we had a nickel cadmium battery, that is a design available to us, and it has had only 12 ampere hour capacity. That means you cannot support all the payload all the time. You have to manage. So, but then it has to go from Earth to low Earth orbit to the sea. So initially, what happened? This configuration, once it is launched or something, this is the point where that booster rocket is attached, and where it will take care of the satellite. So power is needed. So initially, when you launch it, you will be on battery, but you can't be long. You have within about half an hour to 45 minutes or so, you have to come on to the solar panel power for this. So what to do is that we have, though I had that 5-panel configuration, is one from here, one small panel from here will be deployed. That means this will generate power for whatever the requirement. So we had all this. So we thought that everything is taken care. There's nothing wrong in that. Everything was there, is all there. See, we have tried to issue the command to deploy once, twice, nothing is happening. And there is no power on the satellite. And panels are stuck like this. Sun is here. The sun is actually, it's grazing it like this. Sun is coming from this side. Nothing is there. And we have to survive. How we have to survive? So then nothing is, because this, you can't do anything. Because there is nothing in the satellite which will be able to. So then how to understand what is going on, what is wrong with it? We didn't have that so-called simulations. Okay, then we put the first thing is, what you do is, in kind of a spacecraft anomaly, whatever it is, first to put the spacecraft in the safe condition. In the safe condition, without power, nothing. Inside there are so many heaters and things like that, it will not be working. So whatever the power that these antennas, these solar panels can see, tilt the satellite to that condition and leave it like that. And we managed this. 1 week we managed it, because this is the way that it is, why we like. And in the meanwhile, we're trying to understand what went wrong. See, everything, we checked the alignment records, we checked all those kind of things, and why it is not working. And you know that, see, all these mechanisms are coming with certain hinges. Those hinges at room temperature. That means at room temperature is number one, and number two is they are assembled in gravity condition. Okay, when there is for all this temperature related issues, you will have the extra margin in the springs and this thing, and also you will have the margin in terms of the gravitational force and things like that. But why it is not coming? So one idea came is that just because it is aligned in all these mechanisms are tested in the lab, which is in the room temperature, creating the room temperature at this space, I can't do much about it if I want, because the hinges are inaccessible corners. So then we came up with an idea. Why don't you barbecue the satellite? See, literally we barbecued. Like most of the people who go for the party, they put their eatables in the stick and then put it in the fire. So what we did is we designed an operation which will say that it will rotate thinking that yourself as the sun, I exposed it backward sometimes and then make it happen, go all the way to this side. This side is some more hinges are there. So we did it for every day. We tried 4 or 5 because it consumes fuel also. How do we handle? And it is moving in the orbit. So we did all this thing, and finally after that all the things, it just opened up. So it gave us a lesson saying that where you assemble and how you assemble is one of the criteria. So later on, what we always try, the way that you assemble, that is Once again, whenever you want the operation, you have to create back almost near to that one, then only you attempt it. After that, we didn't have any failure. One other funny things happened. We went for a different type of antenna configuration. One of the satellites that has been attempted. You might have studied about this. It's like a unfallable moment. Okay, normally these structures are all, it's about a few 2 meter or 1.5 meters. So we wanted to have some other, we wanted, as Dr. Senthil would appreciate, we were looking for the better link margin. So we went for a larger size array. But at the last moment, it didn't fully deploy. It almost like 80 to 90% it deployed, but it didn't deploy the full. And then after so many this thing, we realized that certain of the elements got a negative temperature coefficient. See, when we use the motor to pull it out, but the temperature used to pull it back. So it is a battle of gain and loss. Whatever we try to pull electrical force from the ground, and then when you leave it, will pull back once again so that it doesn't go to the final equilibrium condition. Okay, then how do we overcome that? So then we designed a maneuver exactly when there's no sunlight, we did that and we were successful. So all these things, why I'm saying all these things, it may be simple things which will be there in that. What was the thing is that you have to observe why and where we went wrong and how we are able to, whether we are having a handle on that and anything, and you could have seen that. Don't feel ashamed about the failures. Failures do happen. We all learn. Okay. And I was just mentioning to you on the earlier, this one is that there was a first satellite INSAT 1A. It just worked for hardly 6 months. And of course, it was not, it was in that so-called warranty period. It is not operated by, we were all there, but we were all supposed to be in the background. Only the contractor is there is a foreign agency. They were supposed to be the person who is supposed to be doing the commanding of the spacecraft. One fine morning, one afternoon, it just gave some problem, and we lost somewhere around 2 o'clock in the afternoon. We lost contact with the satellite, and those foreigners were trying all sorts of things, who claimed to be, like, for example, they were all experts in their own field, and they were trying all sorts of things, but nothing happened. 4-5 hours, nothing had happened, and they almost given up. And at that time, we were all in the background. We didn't have too much say in that those days. Okay, we were all brown people those days, you can say. See, only those foreigners are all, they are knowledgeable, we are not knowledgeable. So that we can say we are brown-skinned people those days. So then finally the mission manager gave up, and then okay, if you want to do anything, you do. The first thing what we did was, we lost contact with the satellite. First, anybody who loses contact with the satellite, first thing is you have to once again switch on the transmitter which sells you the signal. We just send a command. Once again, we just send a command. Then we realize whatever the data that comes from this one is, the satellite is almost dead, no fuel, nothing. It has happened. Then next day we have to declare that the satellite is unusable, so it is lost. So if you analyze and see that there were so many things have happened and see, for example, they were supposed to have the switch. The original configuration is that we are supposed to share the one common transponder, both for telemetry, that is information from the satellite, and as well as the payload information. That switch did not work properly. Number one, it could have, if you send a command again, it would have worked. So that didn't work. And whenever there is when the spacecraft is losing its orientation, there was a safety mechanism which is supposed to inhibit any kind of thruster firing. So that safety mechanism gave active signal, but one wall closed, other wall did not close. So what happened? But the control system went on driving the satellite, and finally it went out of fuel. So it like this, and these kind of things, when you sit and do that, and they were also quite surprised, and each of the team members, they didn't have the proper communication between them. What the control system fellow has done, certain things he has not documented properly. What these kind of things. Another thing is that operationally, the people thought that just because that they are experienced, This is the way satellite has to behave. Nobody thought that there will be a simple failures like this, that uneven kind of a failures that can happen like this. So the first lesson that what we learned is document whatever is the same. That is why in the space regime, things are costly or things are time consuming because documentation is more essential. Each and everything is supposed to be documented properly. That we pay a lot of attention to the documentation. After this failure, before 1 week came, the boss told, okay, they were not very good in documentation. You people, whatever you know it, you better document it. So that is how we learned that each and everything is getting documented. Coming to the documentation part of it, I will tell you one more experience. In the same series, INSAT 1 series, we went to the 4th satellite, that is the INSAT 1D. It's all packed and it's all like this. Once again, it's almost same configuration. We came to this condition and we were supposed to, put it onto the top. We were trying to transport it to the launch vehicle. It's all ready. It's all fueled up. And see, there in the configuration is that there will be one fuel tank. It will be just sitting on this side. Everything was assembled. And this one, in that condition, when we normally in assembly and lifting of these structures, you will be using cranes. The crane hook exactly fell on this satellite, like this. And there is a antenna, which is a fiber structure. The antenna got crushed. It was lucky that it didn't go so deep into the fuel tank. Otherwise, it would have been explosion. Then why I am connecting it to the documentation was that till such time, everybody thought that once the satellite is fueled up, there won't be, you have all this locking mechanisms, I think, so that fuel doesn't leak out or something like that. There was no procedure existing at that time how to drain out the propellant, because we have to take out the satellite back for repair. There was no documentation. Then what we insisted was that some 2-3 days in that condition, what people have worked day and night, we made the documentation. How do we drain out the propellant which is sitting there in these 2 tanks before we touch the spacecraft? Because it's very, very corrosive. I think we were using bipropellant because it's a hypergolic. When you say hypergolic, you don't need a spark plug to make them ignite. Anywhere it comes into contact, and these 2 comes into contact, explosion takes place. So we have to handle safety and we have to safely drain out the propellant. So we based on this experience down the line, somewhere in when I was in Antrix, I was handling one of the international contracts, the same condition. The satellite is fueled up and sitting in French Guiana, the Kuru. I asked, things have changed. It is not foreigners. It's more like our own ISRO colleagues who are specialists in the propulsion related area. I asked the thing, where is your, I thought that I had the authority to ask the paymaster. And I asked, where is the unloading procedure? He jumped on me and said, who are you to ask that type of questions? Because we had bitter arguments and saying that such situations will not come. You don't need a documentation. You don't need. So then he said that no, because up to beyond certain level, because I cannot. I'm not the. Though we raise all the concerns and something that okay, it's the top management which clears for further operations. I agree. So luckily that mission went through. But down the line, you might have seen that there were certain missions which were recalled back at the last moment, which needed these draining procedures. Whatever that you have propellant that is loaded, you need the DLC. So one thing is there. Let us not what we learned and what we are trying to get. It's not that all the time that things will work in the way that you like. You have to be prepared for something untoward. Think about it and then put down for example, there is a famous saying, the palest ink is better than the most retentive memory. You may be having everything in the memory, but doesn't work. At the time of crisis, you need a sheet of paper to look into that and then do this kind of so that you need a documentation. Second one is like repeating that word like James Bond movie, never say never again. Some people will say never say, okay, I don't need this. We always would say that never say never again. It will not happen means there is a likely chance that it will happen. When it happens, are you ready to handle? That is the situation that is, that's much more. It's applicable to all fields of life. See, for example, whatever has happened in this pandemic period, who thought that, you need oxygen supply this much? Okay, you had this kind of, because some down the line that you need certain of this infrastructure kept into the beginning. So this is another thing that what you were saying that I just wanted to say the importance of the documentation, importance of the understanding and the failure. And the third aspect that what I would like to stress upon is that don't give up. If you give up, you are not going to meet the requirements. The critical components in the satellites have failed. I had a situation, payload, everything is perfectly working. So, okay, we had a situation where the satellite is beautifully working. Unfortunately, the backup battery is not there. It works only during sunlight. So, when there is no sun, batteries are failed on board. We have a situation, how to handle. How do we put this satellite into use? So then we just again took the principle of physics. In the physics, you have the one of the concepts. This thing is a spinning body will be more stable. I mean, you have studied about the inertia numbers, the moment of inertia, and things like that. If you have a box type of structure like this, and let us say that if your moment or the moment of inertia is maximum along this particular axis, a rotation about this axis is going to be more stable than the rotation about this particular axis. So unfortunately, studied about all these inertia's numbers, and we have this one. We put it in such a way that when there is no sunlight, we return to the old concept like the spinner. We put the satellite in a spinning condition. It will be stable with respect to attitude wise, but it won't be usable because the way that it is, okay, fine, no problem. So we had geo satellites, we experienced 45 days of eclipse in two phases. Like the one will be centered around September, other one will be centered around March 21st. So this 45 days, your satellite is not available, no problem. But at the end of the 45 days, it will come back. So we design maneuvers, it will come up and we will recover, and we used to do that. So this is one satellite we managed. This experience gave us one more thing. Another critical satellite which lost its critical sensors used for attitude management. How do we manage? So whatever the data that sensors used to give, we used to feed it from the ground as if we fooled the control system, saying that whatever the target information, whatever the processing required for the control system, onboard control system, we used to feed it from the ground. So essentially, we kept the man in the loop. The man is supposed to be sitting in the ground, and man in here later on he replaced by the machine, because initially we were doing manually, but afterwards we put some algorithm and look at some certain parameters, and we generate certain sequences, and then we used to give it. This way we handle the satellite till its last. In the initial years, maybe second year or third year it happened, probably second year it happened, but we kept the satellite alive for next 13 years. So this is one of this thing. Why I'm saying is, if any other people would have given up, but don't give up. That is one other issue that what is the one essential thing that what we have done. Then this is the third aspect. Then you will have this, many people you all would have traveled in aircrafts and things like that. The aerospace industry uses always redundancy, because we are all looking for redundancy. Okay, hardware wise, you will be having the redundancy. And what happens if there is supposed to be certain calculations which are supposed to be done for critical operations? How do we do that? So then we came up with this is that there will be two teams, totally independent approach. Okay, if suppose somebody is following certain algorithm, the other team will follow totally different algorithm, and the results have to converge. And unless there is a match between these two, the operation will not be planned. This is a way that we have taken it to such a level, saying that it used to be a joke before we issue a data. I mean, let us say, for example, something, the spacecraft has to be given certain data, like say 22.3245, and higher management used to comment that first decimal will be given by X, second decimal will be given by Y, third decimal will be given by Z, like that. It used to be, when you want to improve upon the precision mechanism, independent thinking is the one that actually gives you only to say that there are many routes to achieve the same thing. Some may be shorter, some may be longer, but the question is, are we reaching the destination? That is the one, that is what is needed. So you may have, for example, your final results may be, why to spend? Why one team is sufficient, it is not possible to think. But whatever be your limitation, have an independent cross check. If computer is doing certain things, simple thing is manually calculate and check whether it is all fine. That is another way of doing it. You don't need two teams. Okay, there is somebody has written a program and somebody is giving you the results. The computer gives it. Don't believe the computer. So this is what had happened. Sometimes what happens, somebody has fed the wrong information into the computer. So you got the results and believed the computer timing is there. So you uplink to those commands. Satellite looked at different direction. And they realized that it is somebody has given a wrong input. So there are some people who questions each and everything, because the questioning mechanism, if you build it properly, that is another aspects of this one, is the one that is shaped.
Hi sir, Vishesh here sir. Sir, I'm just wondering, okay, like back in those days in 70s, 80s, like we didn't have those technology as what we have right now, like those very precise, accurate technologies, right? So that's just a bit technical, but I was wondering how did the satellites then perform those very precise station keeping requirements? Because most of the satellites at those times were probably sent at the GSOs or the SSOs, the sun synchronous orbits, right? And the sun synchronous orbits falls around 600-800 kilometers, where you have a lot of atmospheric drag and everything. And to maintain the lifetime of the satellite, so and then you have the moon, pull of the moon, and then the J2s and all those things. So how exactly like did they perform such accurate station keeping requirements?
Today, like, you may have all the best tools, but algorithms have not changed much. It's the same algorithm. Okay. See, you might have added some more terms to that, you may get an accuracy number. Like, see, when you have the pi, 3, whatever the number it is 22 by 7, and you can expand whatever you want. And those days, the computers, what we had is, let's say, 8-bit computers or 16-bit computers. I agree. But today, you have 64-bit machine, your accuracy numbers is something is better. See, okay, what happened used to be that in order to arrive at accuracy, to answer your questions, the observations have to be made more often. So that will tell you, that refine that what your number, that what you need to do it. See, it is again the same technology what our ancestors have done that. See, they were also predicting all that, you have that so-called panchangs. See, they say that today we claim they are more accurate, that when that Grahan is going to happen and all those things they have done it. They didn't have any algorithm. They only believed in the algorithms, and the thing. Once you are having a correct algorithm in your hand, it might have taken some 1 hour calculation, I agree. But whatever the results that you are trying to do that is what is more and this. Okay. The same thing. I'm not trying to boost myself. I did my thesis in image processing. I did it in, we didn't have computers. We didn't have, hardly speaking, there is a TDC 16 computer, that means 16-bit TDC, that is ECAL computers. They used to run only COBOL. COBOL is a commercial software, the accounting software. That only they will write. We have to do the punch card business. That only they do it. So we have to request the computer center people. So we did it and also. And I joined. I somehow finished my thesis and for the degree, and then came to the same program I ran in my master control facility using the computer. What used to take for me about 3 weeks time, nearly about 1 hour computer time. 3 weeks time means because the error correction and all that, because those will not load. What used to be the running time of 1 hour in my college days, it used to be giving results in 10 minutes. I'm talking about 1982, where our computers were having memory of 192K. It is not even MB. We are all Ferrite core memory business. So, algorithm is, as long as it is fine, you will be able to get the results, whatever. That is how the people have moved even deep. For example, the moon and beyond. Those days, whatever it is nothing but the calculation. I don't know whether anytime you have used the slide rule. See, people have forgotten slide rule. We have forgotten Clark's tables. Right, because it's already calculated, and my brother's son, who recently completed mechanical engineering, and I asked him, have you bought the design data book? Because in our times, whatever the machine design people used to carry one design data book. There's a big
red color book.
Some kilogram book. That's it. And then how many classes of drafting classes you attended? No, that is all. Now only CAD classes. There is no drafting class. He doesn't know. He has not purchased a mini drafter at all. So it's like this only. So there is evolution is that it is going on, but we have to accept and proceed. Accuracy numbers, I agree with you. You will get to the thing. Then you have to account for it. This is how the uncertainty goes. I will just do this. Thank you.